Okay, so this week we are going to continue learning about radicals. And last week we did square roots with numbers. And then week 2 we did square roots and variables with numbers. And so this week we're just going to conclude with cubed roots. So there are higher powered roots, but we're only going to do cubed roots, which means it is an index number of 3. All right, so the problems will look like this. You'll notice there's a little 3 index number, and that's how you know it's a cubed root. And so I wrote out some of the steps if you like that. But step number 1 is we're going to find factor pairs. So we're still going to break down the original problem into factors until we can't anymore. And remember, we don't use 1, okay? So you can always start with trying like dividing by 2 or 3 and continue on. All right, and then we want to keep going until we get all prime numbers that can't be broken down anymore. So since we have a cubed root and there's a little 3 index number, that means we're going to look for triples. And so the rule is we're going to see 3 of the same number and we still only write that one time in front of the radical, okay? Anything that's a single or a double will stay inside. And then the final step is always to multiply all the numbers outside and all the numbers inside, okay? All right, so let's go ahead and look at some examples. So this week we are going to combine them with numbers only and with variables, so let's just start with numbers. So on our first example, we have 189. So we notice that there's a little 3 index number, and so we want to break that down and we want to look for triples. So 189, it's not even, so it doesn't divide by 2, so I'm just going to try 3. So if we divide by 3, I get 63. I wrote that as 6 times 3. All right, and so now 3 doesn't break down, but 63, I know that also divides by 3. So we get 3 times 21. And once again, I like to continue writing my numbers down because I like seeing them all in a line. So that 3 stays, this 3 stays, and 21 is 3 times 7. So all of those numbers are broken down as much as they can go, and so we want to start looking for triples. So I circle 3 3s, and I'm only going to write that once in front of that radical. The 7 is single, and so that's going to go back inside. And so this would be 3 cubed root of 7, and we would be done. All right, let's try example number 2. So we have 512. So I know it's even, so I'm just going to divide that by 2. So we'll get 256. Once again, we're looking for triples because we have a cubed root. So the 2 stays. And then 256 is also even, so I'll try 2 again. So I get 128. And then 128, well, I know that divides by 4, so I'm going to try a bigger number this time. So I know 4, and we get 32. So then this 2, and you really just want to keep track of your numbers because it's really easy to think you've already written part of your answer. And then 32 I think of as 8 times 4. So I'm going to take a little shortcut. 8 is 4 times 2. And so on my final step, I've got 2, 2, 2, 2. This 4 is 2 times 2. I have another one. And this 4 is 2 times 2. So I just want to keep track of everything. So this actually breaks down into all 2s. So that's why keeping track is pretty important. So we're going to look for triples. So here's one group. Here's another triple group. And here's another triple group. And so we don't have any singles or doubles, and so what that means is we won't have a radical anymore. So our final answer is just going to be 2 times 2 times 2, which is 8. And so what that really meant was 8 times 8 times 8 would actually give us 512. Now, that's not something that I know. If we would have known that, we could have saved a little bit of work, but it still works out if you simplify all the way. All right, let's try one with variables. And probably after these two examples, the only thing I add on my next two examples are just more variables. So I've got 270 k to the fifth. So 270 I think of as 27 times 10. And then 27 is 9 times 3. And 10 is 2 times 5. And so here I've got 3 times 3. Now that's pretty much in a line. So if you want, you don't have to rewrite all the terms. I'll show a different strategy. K to the fifth, I do want to see 5 of those. Okay, so now we're going to look for triples. So I have a triple 3, single, single. Here's a triple K, we just write it once. And we have a double. So I'm going to write my cubed root. And then I have 2 times 5. And then k times k, remember we add exponents, so I get k squared. So this would be our final answer. All right, let's try 256. So we have, I know 2 goes in there, so 128. I feel like, nope, we did 512. So we get the 2 stays. 128, I know divides by 4, so 32. And then 32 is 4 times 8. And then 2, that is 2 times 2. This is 2 times 2. And then 8 is 2 times 2 times 2. And then 5 m's. 1, 2, 3, 4, 5. So we want triples. Here's a 2. Here's a 2. I'll put my little root here. I've got double 2's, so I'll put those inside. Here's a triple. And then here's doubles. So my final step is we're going to multiply those together. 2 times 2 is 4m. And then we have the cubed root. 2 times 2 is 4. M times m is m squared. So the number inside for the exponent should always be smaller than 3. All right, and if you want to see some more variables, we'll go ahead and do 2 more examples. So 108, I know, is 2 times 54. So 54 is 9 times 6. And 9 is 3 times 3, and 6 is 3 times 2. I've got 3 x's, and this is just y to the first, so I have 1 y. So we're going to look for triples. I've got triple 3's, triple x's, and then we get 2 times 2 times y. So 2 times 2 is 4, and we still have a y left. All right, let's try 48. So 48 is 6 times 8, which is 3 times 2, and 2 times 4. And then 4 is 2 times 2. So I think I can keep track of all of that. I've got x cubed and y squared. So if we look for triples, I have 3 2's, 3 x's, and single, single, double. So we'll put all of those inside. So 3 times 2 is 6. Y times y is y squared. Okay, so on this week's activities, they look pretty similar to last week. You'll be typing in the numbers where they go. There is only one practice this week, so please email me if you have any questions.